Hey guys, welcome back to another video, and today we are going to be doing a video presentation on equilibrium by Elena and Andy. Now for some context before we get into equilibrium, as you can see here on the picture on the right, these are called reversible reactions. And a reversible reaction is when the products of the reaction can themselves react to produce the original reactants, which is indicated by this double arrow here in between the reactants and the products. And another thing we are going to be mentioning a lot throughout this presentation are forward and reverse reactions. And a reaction going from left to right is the forward reaction, and the reaction going from right to left is the reverse reaction. Now, of course, not all systems or reactions are always at a state of equilibrium, and this is due to the fact of stresses. A stress is an imposed factor which causes an imbalance between the rate of forward reaction and the rate of reverse reaction. And there are three different types of these stresses, which are the change in concentration, the change in temperature, and the change in pressure. Now, and applying these stresses to a reaction will cause the equilibrium to shift to the left or right side accordingly. But what does it mean for equilibrium to shift left or shift right?
So for me to explain to you what it means for equilibrium to shift left or shift right, I made an example reaction on the board here, reversible reaction here. And this reaction is right now at a state of equilibrium, meaning that the rate of the left side of reaction, which is the forward reaction, is equivalent to the rate of the right side of reaction, which is the reverse reaction. So let's say I apply stress to this equation. According to I spelled this name wrong, hold on. So according to Le Chatelier's principle, if a system at equilibrium is exposed to a stress, the system will shift to relieve that stress. So let's say that the stress I applied to this reversible reaction made the rate of the left side of the reaction greater than the rate of the right side of reaction. This will cause the equilibrium to shift towards the right. Now what this means is that the rate of the right side of the equation is less than the rate of the left side of equation. So the equilibrium shifts to the right to increase the rate of the right side of the equation to equal that of the rate of the left side of the equation. So what this does is relieves the stress of the system or reaction and returns this reaction back to equilibrium. Just to add on, when equilibrium shifts towards the left side, it basically means that the rate of the left side of reaction is now less than the rate of the right side of equation, so the equilibrium shifts to the left to increase the rate of the left side of reaction.
If products are added or reactants are removed, the equilibrium will shift to the left, while adding reactants or removing products will cause the equilibrium to shift to the right. Now, when dealing with temperature, the equilibrium will shift to the left when the temperature is increased, and when the temperature is decreased, the equilibrium shifts to the right. For example, if the temperature in the reaction PCl3 plus Cl2 and PCl5 plus 60 kilojoules, then the equilibrium would shift to the right because the energy in the reaction is a product, and this means that the reaction is also exothermic. In addition, the increase in temperature shows that a product is being added to the equilibrium. Because of this, the equilibrium must shift in order to reduce the addition of the extra product. Now, if the pressure in a reaction is increased, the equilibrium will shift to the side with less moles of gas. Well, if the pressure decreases, the equilibrium must shift to the side with more moles of gas. For instance, if the pressure in a reaction with N2 gas and 3 molecules of H2 gas on the reactant side and 2 molecules of NH3 gas on the product side, the equilibrium would shift towards the product side, because on the reactant side there are 4 moles of gas, while on the product side there are only 2.
And that is the end of our presentation on equilibrium. This presentation was made by Elena and Andy, and if you guys enjoyed the video, make sure you guys hit the like button and subscribe button if you want to help out the channel. And most importantly, make sure you guys have a wonderful day, and I'll see you later.